For our last lesson in this topic, we have variation. So first, let's look at direct variation. The statement y varies directly as x, it means that we have y is equal to kx. Alright, so if we have varies directly, it's like we have y here and then varies directly becomes equals k. So this one over here. So we have y equals, this part over here varies directly, k and then x. Now if you look at this equation over here, we can divide both sides by x and then we will get this equation. So what is this saying? This is saying that the quotient y over x is always constant. So hence, that means that if one quantity increases, the other one will also increase. And if one of them decrease, the other one should also decrease. Now, let's look at this example. If x varies directly as y, and x is 12 when y is 18, what is x when y is 21? Now, from here, it says that x varies directly as y, so that means that the quotient x over y is always constant. Now, it's like we have two pairs of x and y here. So for the first one, when x is 12, y is 18. For the second one, we don't know the value of x when y is 21. So from this equation over here, okay, so we have x over y. So for our first pair, we have 12 over 18. This is our first x over y. For the second pair, we don't know what x is, but y is 21. So as you can see here, there is no need to solve for this constant, right? Although from if you look at your equation, if you look at your equation over here, this is actually our constant k, correct? Okay? Anyway, so let's proceed. So before we solve, we have to simplify first. So this becomes 2/3 equals x over 21. You can do cross multiplication. So if you want cross multiplication, we have 2 times 21 equals 3x. Divide both sides by 3. Now take note, I did not multiply 2 times 21 here because I know that I will divide by 3. Okay? So we have 21, 3, 7. Cancel. So my x is equal to 14. Or what you can do also is from here, I already know that in order to get 21 from 3, I multiply by 7, I mean. So I multiply this by 7. You can also do that. That's faster. So we now get that x is really equal to 14. So the answer is letter B. For the next example, we have a word problem. The weight of an object on Mars is directly proportional to its weight on Earth. An object which weighs 25 kilograms on Earth weighs 10 kilograms on Mars. Find the weight of an object on Mars if it weighs 15 kilograms on Earth. So let me just write a table also here, and then weight on Mars and then weight on Earth. So on Mars, for our first one, object which weighs 25 kilograms on Earth weighs 10 kilograms on Mars, right here. Now, we want to find the weight of an object on Mars if it weighs 15 kilograms on Earth. Now, it says over here that the weight is directly proportional. The weight on Mars is directly proportional to its weight on Earth. So that means, since we have direct proportion, the quotient m over e is constant. So let's do that over here. So we have, from our table, 10 over 25, this is my M, this is my E, is equal to, we don't know the weight on Mars, and then on Earth, it's 15. So just like what we did earlier, let's simplify first. So we have 10 over 25 is 2/5. Then this one, I will do the shortcut that I did earlier. To get 15 from 5, you multiply by 3. So therefore, 2 times 3. So on Mars, it will weigh 6 kilograms. The answer is letter B. For the next variation, we have inverse variation. The statement y varies inversely as x means that y is equal to k over x. So whenever you see the word inversely, that means that the second variable appears in the denominator and k appears in the numerator. If you compare that with the direct variation, so remember for direct variation, okay, x appears together with k. Whereas for inverse or indirect, the second variable appears in the denominator. Alright? Now, if you will look at this equation over here, if you multiply both sides by x, we get this equation. Xy is equal to k. What is this saying? This is saying that the product of x and y is always constant. What is an interpretation of that? That means that if one of them increase, the other one should decrease. They always have um, opposite directions. If one of them decrease, the other one will increase. Right? So if you have inverse variation, like in this case, y is equal to 3 over x, it just so happens that 3 is my constant k. The graph will look like this one. All right? Now, let's look at this one. Given this table, y is inversely proportional to x. Which of the following could be values for x and y? Now, remember, it says that y is inversely proportional to x, so that means that their product is always constant. If you look at this first option here, the product of xy is 8. Here, 3 times 6 is 18, so cannot be. Okay? For the second table, 3 times 5, get 15. 5 times 7, that's 35. So cannot be because they have different products. For this one, this is -2. The product here is 2. So that leaves us with this one. Let's check. The product here, xy, let me just write it here so that you can see it clearly. So the values that I'm writing is the product of x and y. 18 times 1 is 18. 9 times 2 is 18. 3 times 6 is 18. So as you can see there, their product is always equal to 18. For the last kind of variation, we have joint variation. For joint variation, a variable can vary with more than one other variable or with powers of a variable. So joint variation, it's like a combination. So for example, we have here y varies directly as x and inversely as w. So that means, remember, if you have y varies directly, if it's just y varies directly, we have y equals kx, right? But since you have inversely, that means that the variable appearing over here will appear in the denominator. And similarly, for this one, y varies inversely as the square of x. So varies inversely, that means that this variable over here will appear in the denominator. Okay? So let's look at this example. The quantity P is directly proportional to the square of Q and inversely as R. How does P change when both Q and R are doubled? So what you need to do here is, first we have to um, translate this sentence over here. This one, okay? P is directly proportional to the square of Q. So that means P directly proportional. So I have my K and then directly proportional. So sorry, directly proportional to the square of Q. So we have KQ squared. And then inversely as R. So R appears in the denominator. So this is the relationship between P, Q, and R. Now, in order to answer this question, how does P change when both Q and R are double? So what you need to do here is whenever you have problems like that, you always use substitution. So I make a table to make it easy. Old and then new. And also for this type of question, I always let K be equal to 1 just for simplicity. For simplicity. And let's say, now take note here that Q and R are my independent variables. Independent, meaning to say this one here, P, is my dependent variable because it depends on the values of Q and R. Okay, so that means, okay, my independent variables are Q and R. So for simplicity, I just always make them 1. And then remember, our K is 1. So what is now the value of P if Q is 1 and R is 1? So if we plug it in here, K is 1, Q is 1, R is 1. So that leaves us that P is also equal to 1. Now, we have here that we want Q and R to be doubled. So that's why I always started with my old values as 1 so that for the next column, it will just be easy. So my Q and R here will be doubled, but since the original values are 1, so this will be both 2. Let's solve for P. So we have K is 1, Q is 2, R is 2, correct? So what is this? We have 1 times 2 squared is 4 over 2. So the answer is also equal to 2. So what happened? From P equals 1, it became P equals 2. So therefore, the answer is P will also be doubled. The answer is letter A. Next, let's look at this one. We have if y equals 1 when x equals 8 and y equals 4 when x equals 2, which of the following could express the relationship between x and y? So in order to answer this, make a table involving x and y. So let me just write x, y, when y is 1, x is 8, and y is 4 when x is 2. Let's see Roman numeral 1. It says y varies inversely as x. What does that mean? The product xy is a constant. So I'll make a row, for xy. So 8 times 1, we get 8. 2 times 4, we get 8. Correct. So 1 is true. Y varies inversely as x. For Roman numeral 2, y varies directly as the square of x. That means using k, y is equal to k times, because we have varies directly, so y is equal to kx squared. Now just so that I want my k, I want to isolate k. I want to solve for k here. What do? Divide both sides by x squared. So we have y over x squared. I want to check if y over x squared is this constant. Let's see. I'll just copy my table here. So I need my x squared. Just put it here. This is 64 and then 4. I'll try y over x squared. So in this case, y is 1, x squared is 64. In this case, y is 4, x squared is 4. So it's not constant. Alright, let's look at 3. Y varies directly as x. So that means y over x is constant. Let me just erase that so that, okay, we have y over x is constant. Maybe I can just put it here, 3. Y over x. So here my y is 1, x is 8. For this one, my y is 4, x is 2. So it's not true. 1/8 is not the same as 4 over 2 or 2. So therefore, the answer is 1 only.